just like homework.
This one? What do you mean?
We just use the example
Yeah.
or this.
Well, for this one or for the last one?
I mean, today we talk about.
Talk about this, yes. But do you want to do? You want to do something from this?
No.
No. Well, we can do some tutorial in a few classes. Anyways, I want to see here, Gav, if this video is here for you. YouTube.com. Let us see. Slow internet. And slow computer. And slow teacher. Everything's slow. Okay. Oh, come on. Here we go. Okay, playlist. You look in here, do you? Playlist.
Yeah.
Yeah, playlist. Okay. Oh my goodness, come on. I had too many sweets for lunch. Too much sugar. Oh, you have it open. Is it? Can I see the playlist?
Just the resolving.
Yeah, but go back to the playlist. I want to see what's on the list. Yeah, okay. Let's see. Physics intake 2. 6 videos. Yeah, the last one. You're right, Ben. The picture of the race. The last one. Can you see?
Oh yeah, I didn't find this one.
Ah, yeah. You can watch it tonight. Yeah.
Yeah.
Okay. Let's continue. So. Oh, go away. You're tired as well? I think.
Didn't sleep well.
Yeah. I think Ben is the only one who's not tired. Yeah. How come you didn't sleep well? What's the reason?
Me?
Yeah.
After I back home is already around 9. Because I take train after.
What train do you get?
Just out of Shale.
Yeah, but I mean what time?
Around 8.
8 o'clock train.
Yeah, and walk back home around 9.
8 o'clock is kind of late, yeah. You get home at 9 o'clock.
Around morning, later.
Later than 9 o'clock, yeah. Mm.
And do my chemistry homework and then watch the video.
Yeah, maybe you would be too tired to watch 2 videos last night. Maybe it's better to watch one.
This one.
Yeah.
So
Sometimes it takes a while to update on YouTube.
Yeah.
Yeah. I don't know why. Okay, we'll continue now with our next lesson. How was your chemistry homework? What were you doing?
The mass. What's that called?
Draft
Mass.
picture.
Mass spectrometer.
Okay.
Yeah. That's good, okay. We'll actually study that a little bit next semester.
Okay.
A little bit, mass spectrometer. It's in the section called fields. Do you remember this word, fields? Magnetic fields, yeah. Okay. Right, if you write this down, kinematic equations of motion.
I will copy.
Do. Good idea. Yesterday, Ben and I were talking about UVATS. Do you know these letters? in physics? UVATS?
Yeah. You.
V0
Yeah, Ben was saying you call it V0 and VT.
What is crazy?
Well, maybe she calls them UVATS. Is it different education in different parts of China? So we have UVATS yesterday, but Ben was saying in his school that was called V1 VTATS, wasn't it?
V0
V0, you think? And in America,
V0 and A times VT.
yeah. So which do you use? Do you use U and V or do you use V0 VT?
V0 and VT.
Ah, okay, it's the same. Here, we use these letters.
Okay.
So Ben, maybe you can tell us, what does the U mean?
the inter first speed
The
star
initial,
beginning
beginning velocity.
velocity
And the V?
is final velocity.
Good, final velocity, good. A?
Something great.
Yeah, what's it called?
Change.
Yeah, what's it called?
Accelerate rate.
Yes, acceleration. T?
10
Time. And S?
length.
Yeah, displacement. Position.
Position.
Yeah, displacement, yeah. So you have these in China as well. So, let's see. Now, what we're going to do is prove some formulas. But before we do that, some definition. Uniformly accelerated linear motion. Okay, so one word at a time. What does motion mean? Motion means movement. Yeah, okay. What does linear mean? What word is this like in English? What word does it look like? Line, yeah. So what do you think this means, linear motion? Yeah?
Same as the math.
Yeah. So like, what would that mean if I said something is linear motion? Yeah, what were you going to say, Ben? Or yeah, it's moving like this, a straight line. Accelerated means it has acceleration. And yesterday, we were saying acceleration is the change in velocity over time. Yeah. And what does this word mean? Uniformly. Uniformly. What's that mean? Any ideas? No ideas. Uniformly means not changing. So what it means is the acceleration is not changing. So the definition is it's motion which is in a straight line, that's linear, has a constant acceleration. That means uniformly accelerated. You know it now.
I know the Chinese.
Yeah, so you need to know the English. Would you say, Ben, this is very common in physics?
Yeah.
Very common in physics. Okay, so if you can write these words down. I had too much sugar for lunch and now my teeth are sore. And I had too much sugar because I'm tired and I want energy, but it didn't work.
Yeah, that's European love of sugar.
Yeah, too much sugar.
My uncle is saying he just eats chocolate all the time.
Oh, that's not good. That's not good. Is this your uncle you live with?
Yeah.
Yeah,
The Irish.
Irish uncle, yeah. Oh, he's Irish and your aunt is Chinese then, I
Is
see.
she already Irish?
Oh yeah, but she was born in China.
Yeah.
Yeah. She looks Chinese.
Yeah, she
Yes.
is Chinese.
She is Chinese,
Just
and he's
married.
Irish.
Yeah.
Yeah, and he was born in Ireland.
Yeah.
Very interesting. Very interesting. Have they been to China? Have they visited China?
Yeah.
Yeah. Okay. Oh, lots of times. That's good. That's good. Okay, you have these words? Yeah. So, what does this graph look like? So yesterday, Gail, we were looking at these graphs where you have time and you have velocity. So, what would this graph look like? It would look like this. Not this. Not this. Not this. Must be this. A constant acceleration. Okay, that's fine. That's fine. You've done these graphs before?
Yeah.
Yeah, you've seen this one before. Okay. Let's see what equations we can make. Right. So, Ben saw this triangle yesterday, and he thought it was amazing. Yeah. What goes on the top of this triangle? Do you remember? Begins with D. Begins with D.
Decision.
Distance, yeah.
Distance.
Distance, yeah.
Okay.
And then
Speed.
speed and time. Have you seen this triangle? See, they don't teach you this in China. No, it's, let's explain the triangle. So if you want to know the time, then it's distance over speed. If you want to know the speed, it's distance over time. And if you want to know the distance, it's speed multiply time. It's got like 3 formulas. Distance equals speed multiply time, speed equals distance over time, and time equals distance over speed. It's useful, I think it's useful, yeah. But you don't see this in China. I'm surprised. And what's the name of this triangle? It's called the distance speed time triangle. Yeah, so easy to remember. Okay, so anyways, there's a problem. You can only use this triangle if the A is 0. Now we can see why. For example, suppose I have UVATS and I want to know the S. Well, the S is the distance. No, not quite, but usually it is. The S is the distance. So you say, oh, distance is speed multiply time. But here's the problem. You have 2 speeds. You have the speed at the start and the speed at the end. So then the question is, which speed do you use? What do you think now? Do we use U? Do we use V? Do we use both? How? Yeah. Yeah, go on. So what should I write? V?
What's that called?
No. Well, okay, subtract. Subtract or minus. V subtract or minus U.
Yeah, that's the speed.
Oh, so you say with that multiply T. Speed multiply time. No, not quite.
Yeah, that's it.
Not quite. Any ideas, Ben? So let me tell you, in physics, when you can only use one value, but you have 2 values, or maybe 3 values, or 4 values, what you use is the average speed. Average. You know this word? Average? Yeah, so you use the average. So this is our first formula. S equals U plus V over 2T. And I'll call this formula 0. because it's a basic formula, formula 0. Oh, before I continue, I should tell you, they could ask you to prove these formulas in the exam, the proof. You know, they could ask you to show this. So you need to know how to prove this. So you prove this using the triangle. Yeah.
So we draw a triangle.
Just draw a triangle. Yeah. Yeah. Okay. Right. Next formula. Next formula. Next formula. You have just this rule. Acceleration is change in v over time. Yeah. So that one gow is v minus u. And the time will be t. So you can change this into at equals v minus u, which means v equals u plus at. This is equation 1. And the proof just comes from this definition. That's all. Okay? So if we can write this down.
How to call the English? Like,
Oh, now maybe Ben remembers. Ben, do you remember what this is called?
Delta.
Very good, delta.
Delta.
Yeah.
It's the same as Chinese.
It is the same as Chinese, yes, because it's Greek. Let's see if Gail knows her Greek letters. This one?
Alpha. Good.
Gamma.
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 Delta.
Delta?
Yeah,
So, okay, like the big one, the small.
that's it. Do you know this one?
E?
Yeah, no. Epsilon. Epsilon. Do you know this one?
Gamma. I know this one.
Do you know it, Ben?
Oh, I forgot.
Omega.
Omega.
And I'm sure you must know this one.
Pi.
Yes, you must know this one, yeah. Okay, continue now. So that's that rule. Now next. So what I'll do now is I'll put 1 into 0. So I get S equals U plus V, but V is U plus AT. Do you see what I did? I replaced the V with U plus AT here. Because this is V here. Is that okay? Yeah. So you get now S equals 2U plus AT over 2 times T. So that's 2UT plus AT squared over 2. So that's S equals UT plus a half AT squared, equation 2.
That's good.
Okay, so there's only one more formula left. So for the last one, what I'll do, yeah, from equation 1, you can say V minus U over A equals T from this one. Put into 0, put it into this one. So now you get S equals U plus V over 2 times T, which is V minus U over A. Okay? So now you get S equals UV minus U squared plus V squared minus UV over 2A. So you get 2AS equals, cancel, V squared minus U squared. So finally, you get V squared equals U squared plus 2AS. That is our final equation, equation 2. You need to know these proofs. So you need to learn the proof, how to prove it. You need to know. It's not. I think only the last one is a little bit hard. It's a little bit hard. Have you seen these proofs before in China?
Yeah.
You've seen the proof before. A similar proof or a different proof?
That's it.
The same? Yeah. Okay, let's continue. So, we have S equals U plus V over 2 times T, V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. We have 4 formulas here.
And you just say we have 2 different motions.
Yes.
One is A equals 0, and one A is the same.
Uniform, yeah.
Yeah.
So I suppose you're right. We have 2 different types of motion.
I just want to know we can use this equation or no?
Yeah, you can use the 4 equations when A is constant. Okay, and when A is 0, you should use the triangle.
Oh, just use triangle.
Just use the triangle. Yeah, that's all.
Is enough.
Oh yeah, more than enough. Yeah,
Okay.
more than enough. Okay, continue.
Okay.
Yeah. All right. Now, to solve any, we need to know 3. If you have UVATS, you must know at least 3 of them to get number 4 and 5. You can't do this if you only know 2. You know, you need to have at least 3. Then it's possible. Possible. You can, like, it's possible, yeah. These problems are called UVAT problems. SUVAT. But I'm sorry, or UVATS problems. I always call them UVATS problems because that's what my teacher called them. I do like calling them SUVAT because it's shorter, but I call these UVATS problems. But that's longer. So if you want to call them SUVAT, that's fine. I understand. Yeah. So I would like you to say it's a SUVAT problem, but if you look online, you might see SUVAT, but you might see them called kinematic equations. Kinematic equations. But most people call them UVATS or SUVAT. And anyways, this is the name of the lesson, kinematic. Okay. Right. Let's have a look at our first example. A girl is about to start cycling her bicycle. She is at rest and cycles to 9 meters per second in 6 seconds. How far did she cycle? What was her acceleration? Okay, so what I'm going to do, I'm going to ask you to tell me what we know. UVATS. Okay, so do we know U.
Yeah.
Yeah, what's U?
0.
0, okay. Do we know V? No. We don't know. Oh no, sorry. We do know V.
No.
It's 9. Do we know A? No.
No.
Do we know T? Yeah, what's 6?
6.
So, can we get S and can we get A? We can. First we want to know the S.
Yeah.
Which equation can give me the S?
0.
Yeah, which equation 0? Yes. S equals U plus V over 2 times T. So what's it? 27 meters. Yeah? Right, so I know the S. Can I get the A? Yeah, use the next equation. V equals U plus AT. Yeah? So then A equals 1.5 meters per second squared. Right? I hope so. Yeah? 9 over 6? Is okay? Are you sure, Ben? Yeah? Easy? Easy, I think. Not too hard. Not too hard. Okay, shall we do another example? Now this one's a little bit harder because, well, what's the problem here? The speed is, kilometers per hour, and it should be meters per second. So a car is traveling 120 kilometers per hour. The driver sees a crash and suddenly brakes. It takes 100 meters of road for the car to stop. Okay, so again, let us see if you know your UVATS. So tell me, guys, what's the U? Not 0. Not 0.
120.
Yeah, the car's going 120. But we have to be careful. That's 120 kilometers per hour. Okay. The V. No, I think we know the V.
Reach the last.
Mhm.
To rest. So yeah.
Very good. It's 0.
Stop.
Stop, yeah. The A. Do we know the A?
No.
No. No. Do we know the T? No, we don't. Do we know the S?
Yeah.
Yeah, what's the S?
It's
It's 100. So, what should you do first? Change. Convert. Convert to meters per second. And this question, I want the A and the time. How long did it take? So I'm looking for the A and the T. Okay, I'm going to let you try to do this. So I think you can do this one. And then we'll do it together. No, that's too slow. Don't want to use a calculator?
Just I think no. Oh.
Strange. Is that right?
For the A? I think the A should be big. What did you get?
Number T is. I'm not sure the number that I saved is right.
Let's see, what did you get? What number?
No, it's after convert is 3 3 point.
Oh, yeah, I think that's right. I think so, yeah.
It's minus 5.55.
For the A?
Oh.
Maybe. I would have thought it bigger. Let's calculate. So first what I'll do, it's 120 times 1000. Why 1000? 1000 plus kilo. And then hour is 3600 seconds. 1200 over 36. Did you say, Gal, that's 33.33, etc.? Yeah. Okay, so how can I get the A? I could say V squared equals U squared plus 2AS. I hope. Is that right?
No.
No?
No. It's 3, 13, 3, 5, 6, 3.
No, I know. I'm tired. Oh yeah, you're showing me. Sorry. What did I do that was stupid? No, tell me what I did that was stupid. What was my stupid mistake? I did this. I said this squared.
Yeah.
Yeah, stupid.
So
stupid.
why?
Yeah. Why did we do this? So V squared equals U squared, thank you, Ben, plus 2AS, like this. Yeah, 2 times 100 times S.
200.
Oh, for goodness sake, sorry. 200A, thank you.
So
So A is 1108.89 minus over 200. Oh yeah, no, you're right. It is only minus 5.54, about. Yeah, roughly. Okay, what do I need next? I need the T. So I could say V equals U, if I wanted, plus A T. That would be easy. So then I can just say about 6 seconds. About 6 seconds, roughly 6 seconds. Right, that's okay, yeah? Right. Okay, now this one, I'll draw it for you. So here we are. Okay, so she drops a ball, and this building here is 25 meters, and she drops it from rest, and it takes 2.26 seconds. Hits the ground. Okay. UVATS. Right. What's the U? 0. Good. What's the V? Don't know. What's the A? We don't. Yeah. Well, maybe not, because if there's some kind of error, it's about 9. About 9.8. Yeah. But we don't know yet.
Okay.
Yeah. The T?
2.26.
2.26. And the S?
25.
No.
We need her hair.
And
No, sorry. It's, yeah, okay, it's 20. This is, okay, don't worry about that. It is 25 there, yeah. You see, I think it's better if you say the S is minus 25. Because you take this as the origin, as the center.
Okay.
So here, this is minus 25. Because that's different to if she threw the ball up in the air. Now, I would say that's plus 25.
Okay.
You see, that's something to be careful about, the plus and the minus. Yeah. So this means here the V will be negative because it's going down. Yeah. And what do I want? I want first the A. Okay. Will the A be positive or negative?
Negative.
Negative, okay. So, how can I get the A? S equals, yeah, S equals UT plus a half A T squared. So let's get the A here. Nearly 9.8, Ben. Oops. Sorry. A equals minus 9.79 meters per second squared.
Yeah.
Maybe there was some wind. And then what's the V? Okay, so how can I get the V? I could just say the V is U plus A T. Which, what's that? That's about 22.1. So the V is minus 22.1 meters per second. And the minus because it's going down. Wait, but the question was how fast? Fast means speed. So this is not it. I'd say the speed equals 22.1. No minus.
No
Direction.
direction.
Yeah, because my question was how fast. And how fast means what is the speed in English. If I said how fast in English, this means what is the speed.
So how should we prove that we were right just after we
Oh yeah, so after you get V equals minus 22.1, you could just say the speed equals 22.1. Yeah.
Do we use that so in
Yeah, you can use, you mean this?
yeah.
Yeah.
But that's can use
Oh, yeah. Yes, of course. Do you know this one? No? Do you know this one?
Yeah, but that I know that in maths.
You know this one in maths?
Oh,
What's it mean?
I forgot.
Do you know this one? Like this?
Yeah, I seen them in high school. It's too long ago.
This means for all. This one means not. This one means therefore. And this one exists.
Okay.
Yeah?
I hear it.
If you want to write them down, you can. You did these 4 in China?
Yeah, we have this, but sometimes when we prove the mathematics, we will write down the Chinese word like.
I understand, yeah.
I don't know.
Do you
we
know-
have this and only have this.
Yeah.
Have this?
Yeah, that's this one maybe.
What is this?
That one means if and only if.
Yeah.
What's this square?
Don't know.
End of proof. And then this one here? Start of proof.
We
Yeah.
we don't have
We
to
don't have
start
that
and
one.
end.
Start and end.
Yeah, we don't have to.
Yeah. Okay, do you want to write some of this down? There you go. Mm-hmm. Yeah. Continue. Yeah. Okay. So you can see this picture here, the girl dropping the ball, and after 1 second its speed is 10. After 2 seconds its speed is 20, roughly. After 3 seconds its speed is 30. So it's getting faster. So you can see when the ball is dropped, it will increase its speed by 10 every second. So that means the acceleration is about 10 meters per second squared. In fact, the acceleration due to gravity is for us the letter G. And here in this course, we say G is 9.81. Now some places, some courses, they say 9.8, some places say 10. What was it in China did you use?
9.8.
9.8. No 1.
No.
So for us, we use 9.81
Okay.
as the acceleration due to gravity. And we call this number G. So you should write that down. This is the A when something is fallen to earth, like when you drop a ball.
Gravity means air.
Yeah, no, it means the thing that makes it come down.
Okay.
The force that pulls it down, you know. Like this is why does this fall? It falls because of gravity. Yeah, gravity is the reason it falls.
Oh, some reason.
Yeah,
That for
yeah, some reason for falling down. This reason is gravity.
oh.
重.
Yeah, that.
Yeah. We call kind of mass force, like
Force, yeah,
some
force.
like-
Natural force.
Yeah, I remember a person in the physics books. I couldn't remember the name. You know, they put some two things together. To jump
Yeah,
super-
Galileo. No, Galileo. Yeah, he dropped the on the top of the tower. He dropped the two rocks. Yeah, and they fall together. Yeah.
Billy Tower.
Which tower?
Billy.
Is that Chinese?
Yeah.
什么什么斜塔
The tower. What country?
Italy.
Correct. Pisa. Tower of Pisa.
Pizza. Oh. Chinese pizza.
Ah, similar. Pisa. It's close.
底下去。
对对对。
You know the place now? Okay. You got this, Ben? Nearly.
Yeah.
Okay, continue?
Yeah.
Right. Okay, here's a hard one. Okay, a ball is thrown up by a girl with a speed of 50. The ball leaves her hand, and her hand is 1 meter above the ground. The ball goes up, stops, and then comes back to the ground. The girl does not catch the ball. So let me draw the picture here, what's happening. So this distance here, 1 meter, yeah. And the ball goes up, stops, and comes back down to the ground. Right, so my first question, and she throws at 50. So this is 50 meters per second going up here. Okay, my first question is, what is the maximum height? So that's here. Okay, so first let's write down UVATS. What's the U?
50.
Good. Now, what's the V?
0.
Good, because it stops up here and then falls down. Yeah. We're just looking here to here. The first piece.
The first.
Yeah. Yeah.
She can throw the 15.
She's very strong. She's very strong.
Don't care too much.
No. Well, Ben does.
Okay. I don't care.
She's strong. Okay. Right. The A. Do we know the A?
No.
Well, we do now.
G.
The A is G. 9.81. Now, careful. Is it plus or is it minus?
Close.
No. No. Minus. Minus G. Because it's all, the G is always going down.
Oh yeah.
The minus is because it's down.
Okay.
Yeah. The T we don't know, and the S is what we want. Okay, I'll give you 1 minute. Get me the S. Maybe V squared equals U squared plus 2AS, I think. This formula. V squared equals U squared plus 2AS. And get the S. Sure, no problem. You're getting the T first, is it, Ben?
Yeah.
Okay. What did you get?
127.
Okay, that's the S. And Ben's getting the T.
5.09.
5.09.
Should I get after find the answer?
No, that's okay. 127 meters. Now that's not quite the answer. The answer is actually 128 meters
Yeah.
because of the extra one. Yeah? Okay. So we got part A and part B. We got the maximum height and the time. Oh no, sorry, the next part. How long until the ball hits the ground? Okay, now let's do that part. So now we're looking at from here to here.
How long?
How long means the time actually. Yeah. I know the English is terrible, but how long means the time, not
Yeah.
the distance, yeah. Okay, what's the U?
It means
From here to here. Yeah, what's the U? 50. The V, we don't know. We don't know.
Yeah.
We don't know. The A,
minus
minus G.
2. Yeah.
Minus G. The T, don't know.
Don't know.
T is what we want. And the S,
128.
no.
Okay, so wait, I don't understand.
Yeah, what's the S?
So the displacement.
Yeah. What is it?
Wait.
is
What is it, Ben, do you think?
plus
Yeah?
and 215 feet.
No.
What?
Nearly. So the S, watch carefully, the S is minus 1
Oh.
From the origin.
from the origin.
Oh.
Yeah? So, now we can get the V and the T, because we have 3 pieces.
Yeah.
But
Yeah.
when the ball kick the ground, it's not zero?
No, it's not.
to be.
It has speed when it hits the ground. Yeah. So, what do I want? I want the T. I could say S equals UT plus a half a T squared. Now, Ben and Gao, do you know how to solve this equation? Do you know how to get the answer?
Yeah.
You've done these ones. So you can say T equals 50 plus or minus. You know this formula?
Yeah.
Yeah, you did this one in this formula in high school. Yeah, okay. Let's calculate it.
Is the same T is T squared or
Sorry. Square. Yeah, sorry. Okay. 50
15 squared and minus 4.
Right, I got 2 answers. So my first answer is 10.2 seconds, or now which answer is right and which answer is wrong?
The first one.
Obviously, it has to be
Yeah.
this one, doesn't it? Yeah. Okay, how far does the ball travel? Ben, you know this one. How far does the ball travel? So you calculated that earlier. What did you get?
Is 215 times.
Yeah, it was 1
1
plus 127 plus. Oh, sorry, I knocked this out. Go on. It was 1 plus 127. No, sorry. 127 plus 127 plus 1. Yeah, which is 255 meters. Okay. How fast is the ball going when it hits the ground? So that's the V here. So that's U plus A T. So let's calculate that. Now, why is it minus answer? Well, minus 50.1. Why is it minus? Why is my V minus?
minus.
Yeah. Why is the V minus?
So,
Not because it stopped. Not this.
What is minus?
What is minus? This is minus. And this is
Oh,
plus.
oh.
So, why is my V negative? Why is it minus? Why is it negative?
Why is but because
Yeah, because it's going down. It's going into the ground. Because,
the ground.
well, I mean, it hits the ground. It's trying to go into the ground. Yeah, and it's plus would mean it's going up, and minus means it's going down.
So we may compare with the origin.
Compare with the original, the origin, yeah.
and but he just question how fast.
Was it how fast? Ah, very good, Ben. You're awake. So, how fast means the speed, which is 50.1. Okay, good. Now, last part. What was the average speed?
Average, just the zero.
Average speed. You have a formula for average speed. I don't know if I told you, but I'm telling you now. It's the total distance over the total time. That's the average speed. So in this question, it will be 255 over 10.2.
What is
I think that was the time, wasn't it?
yeah,
25 meters per second. That's the average speed. What's wrong, Ben? You don't look happy with this.
Oh, I'm happy.
You're happy? Okay. It's okay now?
So move up a little bit.
Up or down?
Down.
Average use
Okay.
Mm.
So it's 25?
25 meters per second is the average speed.
But, okay. It seems like if we add the first piece weight and add the second weight together plus over 2 is the same 25.
Yes. Yes.
So is it right or wrong? Just
No, I don't know if it's an accident. I think that's okay. But I'm not 100% sure.
okay.
But if there were two different answers, I know that this is always the right answer.
Yeah.
But I think you're right. I think you could say the speed at the start plus the speed at the end over 2. Because you were thinking, oh, it's 50 plus 50 over 2.
But I think.
Oh no, that's 50. So that doesn't work.
It's 0 plus 50.
Oh, I see. You're looking at from here to here.
Yeah.
Yeah, but I want the average for the whole journey.
I mean, like this, but from this is first piece and this is the second piece.
Oh.
No, because we have way
Yeah.
0 in here.
No, I don't like it. I changed my mind. I don't like it. I only want this formula here.
Okay.
It's safer.
Mm.
Oh, who's this now? Ben, do you mind getting the door? Someone's trying to come in. I don't know who. Who have I got?
No.
No one?
No.
No one.
No.
I think it was a teacher who went to the wrong room. Okay, did you write this down? Oh, good. Okay. You got this? Yeah? Ben, you got this? Okay, so let's have a look. Is there any more examples? No? Okay. This is a good example because it's difficult.
Many tricks.
Many tricks to it, yeah, many tricks. I think I'll let you try these for a few minutes and then maybe in about 5 minutes, 10 minutes, we can go to the next lesson. Yeah, so try not to fall asleep and we can do a couple of these. There you go, Ben. So if you can do your best now to do some of these. I'll close this.